All right. So in this last module talking about fatigue, I want to sort of get to the practical part of it as what we might want to know as designers of materials um, is how to extend the fatigue lifetime of material, right? Because that's useful information, obviously. So there's going to be some different strategies. So let's look at those. So there's three kind of general techniques for improving the fatigue lifetime that we're going to talk about. And the first one is probably the one that you're going to think of automatically, right? So looking at the S&N curve, we see that if we can reduce the magnitude of that mean stress, the stress amplitude S, then we can extend the lifetime. We basically going back this direction. If we decrease the stress, it's increasing the number of cycles that it can withstand, right? So that's always a great option if that can be done, right? Decreasing the stress. So if the design allows for that, that's how we could do one part of it. The other part would be surface treatments. So surface treatments, just like we talked about with fracture toughness, can impose a compressive stress on the surface, which increases surface hardness and suppresses those surface cracks from growing. And you saw from a previous image that there was those cyclic striations on the surface, right? That they're continually growing during fatigue. And so if you can suppress that with compressive stresses, then we can implement longer fatigue lifetimes. And so one way that this is done with materials is shot pinning. And so that's basically where we have a surface and we basically fire small projectiles at the surface, which causes plastic deformation. It causes compressive stress as it's being deformed. And so in this sort of surface region, you put it under compression. And so we can use something like shot pinning on more ductile materials. Carburizing as well, where we flow carbon-rich gas over an alloy, which increases diffuses carbon into the surface, and that increased carbon in the surface, they're going into interstitials, which, as you know, compress the area, and so we create more surface hardness with carburizing a material as well. So anything that you can kind of do this compressive stress. So any of those topics that we talked about with fracture toughness would also work for these fatigue lifetimes. The big difference is typically with these fatigue applications, we're talking about more ductile materials. And so therefore you see like shot pinning and carburization are typically done on alloys and other metals that have a substantial amount of plastic deformation. All right, and the last one that we can talk about. And again, this isn't limiting the only things that are done to improve fatigue lifetime, but the last thing is potentially design changes that can be done. So this isn't necessarily something that I've done, but something that you can think about when you make CAD drawings of things and look at the stresses involved, is that we can remove stress concentrators, just like we try to remove flaws if possible. Right? We don't want to design flaws into the material as well. So if you have a part like this and you have this abrupt, sharp 90-degree angle as opposed to a more rounded corner, right? That rounding causes the curvature to decrease, and it no longer sort of acts as big of a stress concentration, whereas very sharp edges, just like notches, are areas of stress concentration. So design is always a really good option to think about in these parts. And so there's a host of ways that we can do this, improve for a given material. So we can change the design, we can apply some surface treatment, and then reduce the stress. The one that's not kind of said here is that if you have more options in terms of the material that it can be, you could obviously go back to the curve here and kind of pick materials that have a higher number of cycles for the stress that you're you're given. So these options that you're seeing here are outside the realm of picking a different material, but obviously that is something that could be addressed as well if the design allows for it.